Uh, Hello, everybody. I am Abbas Dashtimanesh from KTH University of Technology in Sweden. I'm pleased to give you a presentation regarding the current challenges and opportunities in digitalization of high-speed craft design. In this presentation, first I would like to introduce our objectives, aims, and focus of the paper. That is kind of a literature survey article. Uh, However, instead of going through literature survey, I just will give you our understanding and findings of our literature survey. That perhaps sounds more interesting to you. Uh, Finally, I will mention the current challenges and opportunities for digital design of high-speed planning craft. Actually, high-speed small craft, considering hull design, propeller and propulsion system design, and various onboard systems and subsystems. Uh, you know that the Baltic Sea is highly sensitive to environmental footprint of human activities, I would say. A period of 30 years is required for full exchange of the Baltic Sea waters, while we know that there are many, actually millions of small craft active in the Baltic Sea region, in specific during the summertime. However, most of the regulation address only large vessels, while we know that small high-speed craft are consumers of fuel and lubricant, and we know that contribution of high-speed small craft has almost been ignored in environmental impact studies of shipping. For example, the IMO regulation is just related to large vessels, and many other regional and national and international regulation have the same shortcoming. Therefore, one of the main focus of our paper is improving the fuel efficiency of a small high-speed craft using digital design. I will talk about it a bit more to make it clear what we mean by terms of digital design. Actually, you know that in case of Industry 4 platform, Industry 4 has many different aspects, including, as you can see in the figure, a smart factory, internet, business informatics, and a smart design. As I mentioned, our main focus is on a smart design, including computational intelligence, simulation-based design, and design automation. While we are looking for possible application of machine learning, or I don't know, some other big data analysis and something like that. Actually, by automating the simulation of product scenario using simulation-based design and computational intelligence techniques, it can help in the rapid testing and development of innovative design, which in turn translate to better efficiency that is consistent with the current market demands, such as green solutions in maritime industry, that most of us work on it. Sorry. In this figure, you can see kind of through life a smart shipping network, mainly including a smart design, a smart manufacturing, and a smart ships. We know that there are some progress in this field, but despite a promising start, advances in smart design are lacking in comparison to a smart manufacturing and a smart products. Therefore, based on this finding from studying many papers in our literature survey, we found that one of the main focuses that researchers at this time can work on is related to a smart design. And as you know, smart design has many different aspects in itself. For example, we can consider the hydrodynamic hull design, propeller and propulsion system design, I don't know, automation and digitalization of various systems and subsystems on board of a small craft. All these can be considered in a smart design process. So we divided each part of this design aspects between the member of our team, the partners from Gdansk University of Technology, from the Aalto University, Tallinn University of Technology, and KTH Royal Institute of Technology to work on different aspects of digital design. In the next slides, I will continue my presentation by mentioning our findings in these three design fields. The main design aspects that we can talk about is hydrodynamic hull design. Actually, there are various design aspects that should be considered in a smart design process, including resistance calculation, seakeeping prediction, and maneuvering simulation. Moreover, we need to consider various advanced and innovative hull forms which are more efficient than usual design. For example, we can introduce stepped hulls, tunnels, boats, and hydrofoil craft as demanding hull forms. Last but not least importance, advances in hydrodynamic hull design strongly depends on design methods that can be experimental, numerical, or mathematical models. How can we digitalize our towing tank test, our numerical simulations, even our mathematical modeling? These are some aspects that we can think about them when we are talking about digital design. If you want me to give you more details, I would say that we are all well aware that there is a relatively huge market demand for innovative hull design based on the new requirements that somehow stress the demands for automation in design by considering various hull features. Therefore, I think it seems that we need a kind of smart computational tools for introducing intelligent ship design process. Moreover, application of advanced methods is inevitable, I would say. We need to implement various computational intelligence techniques for developing a smart boat design software. I don't know, something like machine learning, artificial intelligence, evolutionary algorithms, and something like that. But hull design and actually focusing on the hydrodynamics of hull is not the only aspects of small craft design. As Valerio discussed nicely in the previous presentation, there are some advances in propulsion system designs regarding fully electric and hybrid outboard, inboard, and pod propulsion units. But our team believes that we need to go through some digital design for designing this kind of new concepts. We should note that the new propulsion systems and concepts have not been widely adopted yet, partly because of their power limitations, as Valerio mentions. So, in the meanwhile, research on underwater radiated noise, I think, becomes increasingly important. Our literature survey shows that. for commercial shipping, and indeed there is a lack of investigation about underwater noise. We know that how it can be important in the coming years. And again, all this should be considered in designing smart computational tools for high-speed craft design. And for that purpose, our team wants to digitalize simulation of propeller and propulsion systems, design using current software such as OpenFOAM, but we need more investigations. Valerio mentioned that we don't need to go through, for example, some simulations in case of prediction of required battery capacity, but there are still some other aspects of propulsion system design that needs to be digitalized. For example, when we want to design a propeller or the radiated noise or something like that. In addition to hydrodynamic hull design and propulsion system design, as I mentioned, there is a need of optimization and integration of onboard systems that demands application of modern technology, such as artificial intelligence, big data analysis, virtual reality tools, and something like that. Actually, various elements on board of high-speed crafts should be considered in the strategy phase of digitalization of high-speed craft for achieving better efficiency. I don't want to overwhelm you with mentioning the exact references we have studied. I'm just trying to give you a general overview and about digitalization of design and operation of high-speed craft. Please note to that I don't want to mention every single reference here. Finally, after I don't know studying many papers, we reached to this point to introduce various challenges and opportunities regarding digitalization of high-speed craft design. In case of hydrodynamic design, we can go through design of innovative hull forms by digital simulation of sea keeping and maneuvering and resistance calculation. We need to implement evolutionary algorithms and more intelligence computational techniques. And at the end, the most important things that we can we think will be important in the near future is developing smart computational tools. In case of propeller and propulsion system design, again, we need to have a smart computational tools, but the focus will be on optimization of noise and vibration and efficiency assessment using digital tools. And in case of automation and digitalization of systems and subsystems, our partner from Gdansk University of Technology recognize that we need to take some steps by considering various measures. The steps should be monitoring, visualization, and report performance, and other parts, as you can see in the figure. And Valeria also mentioned that we need kind of system management and monitoring. So I think we are on the same page. And the measures are the vessel data collection, controls, and decision support tools, and something like that. To have a conclusion, I think that our team has studied the small craft hydrodynamic, focusing on green propulsion systems, and also digital onboard systems. We have studied through our literature survey the main finding is that we need to go through development of smart computational tools for safe and sustainable design and operation. Combination of emerging technologies such as artificial intelligence and machine learning with the state-of-the-art computational methods seems to be inevitable. Hull form development, safety assessment, and performance monitoring are the main topics of our future research regarding for having a more efficient small craft, and we can't ignore the potential of digital onboard system and higher level of monitoring as one of the most demanding research direction in the first few years, in the next few years. Thank you, everybody, and I'm glad to answer your questions.